Hello, ladies and gentlemen. We are going to be doing skill 8.3 first today. And these are going to be theorems about what we are calling chords and secants. So just as a refresher course here, if you want to see like what the vocabulary looks like, here is a circle and a chord just connects one point to another point in the circle. So this is what I will call a chord. And then a secant is when the chord actually goes outside of the circle. So maybe you have a situation that's kind of like that. And that's what I mean by a secant. So if you need a refresher course, please make sure that you have these terminologies down, because it will help you identify the theorems today. Another pro tip here is to make sure that you are taking good notes and you are matching the pictures to a picture that you see in one of the theorems and definitions that we're about to go over when you are doing these problems today. And it will very much tell you exactly what you need to do. All right, so I'm just going to give you the theorems and then show you kind of with an example of how they work as well. Rather than have you memorize the dense theoremes, I'm just going to kind of tell you about the situation and then what you should do when you have that type of situation with your problem today. All right, so the first one is vertex inside. So we have two chords, maybe they're meeting a little bit outside of the center. So this is saying that the angle is equal to 1/2 of the sum of the two arcs. So if I want to find what the angle X is equal to, I'm going to do X is equal to 1/2 times 70 plus 130. So it just tells me to add the two arc degrees together. And I will just do that. I'll just use my PEMDAS. So this adds to 200. And you get precisely 100 degrees. Every once in a while, you may see in your practices that there will be some algebraic expressions put in there. And you'll just have a little bit of algebra to solve after you have that set up. When we have a situation where we have secant lines that are intersecting, where the vertex is outside and you have two arc measures given, what you're going to do is you're just going to do X is equal to 1/2. And I'm going to subtract 160 and 80. So I'm going to get 1/2 of 80. And I will see that the angle is comfortably smaller than the 160 and the 80. It will be precisely 40 degrees. You may have a problem or two on delta where maybe I give you the angle that's on the outside and it would be a number, and then maybe one of these would be X's. But you can do the same setup and then use algebra to solve. So make sure that you kind of copy these general instructions down and the diagram, or you could take a screenshot of this as well to kind of include in your theorem library. All right, next we're going to look at solving for chords. And what these basically do is you're just going to be multiplying the pieces together. So in order to do that, I'm just going to do the X times 2 equals to the 3 times 4. And I get 2x is equal to 12. And then I'm just going to divide by 2. And I'll get x is equal to 6. For the other problems that you're going to see today, I'm going to give you 2 words to kind of think about. And those 2 words are think symmetry. Now I have, the theorem as what you're going to see in the textbook here. It reads, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc, so like for instance, if I have an x here, and maybe this is 3, then our x would be equal to 3, or if this was 50 degrees and I wanted to find what y was, that would be 50 degrees as well. But rather than like memorizing the theorem, if you have a diameter or the mentioning of a diameter, it divides the circle exactly in half. So I think it is a lot wiser to kind of just think about symmetry, meaning that what is true on one half must be true on the other half. We also have other instances of symmetry as well. So one thing that we notice here is that if these chords are congruent to each other, the arcs that would be created are also congruent. So I could say that 152 is equal to 50x plus 2. And I'm just going to subtract that. And I could solve for x. So I could say that 150 is equal to 50x. And I'm going to divide by 50. And I'm going to get that x is equal to 3. And then I could try plugging that in. So I could do 50 times 3 plus 2 to get me to 152. Or if we have a situation where we have diameters, diameters mean that they are symmetrical. So we could actually say that these are equal to each other because of the symmetry. So you could actually just do, 47 equals to 5x plus 2. Subtract 2 on both sides, and you would have 45 is equal to 5x, and therefore x equals to 9. So in this practice, you want to be thinking about those theorems that I showed you about secants and chords. And then you also want to make sure that when you have things like diameters, that you can use the advantage of that it's symmetrical and that the circles are cut evenly in half. So people who are thinking symmetry are actually using the circle theorems without even realizing it. So thank you very much, and we will tune in for a few more circle theorems in 8.4.